Hello friends, welcome to Electrical Point. So in this video we'll see about the resistance in an electrical circuit. Now see what is the resistance. Okay, suppose this is a conductor and we apply potential difference across this conductor. So due to which there will be electric field generated in this conductor from in this direction from high potential to low potential. Okay, then what will happen? Electrons will attracted to the higher polarity of the potential. So electrons will move against the direction of electric field like this. So what will happen when these electrons will accelerate? Then it will collide with the positive ions that are present in the conductor and with the wall of the conductor. Then what will happen? Their motion will be opposed. So this opposition we call resistance. Now what is the value of resistance? It is rho L by A. If the length of the conductor will increase, R will increase. Okay, and also if the area will increase, resistance will always decrease, and rho is called the resistivity of the conductor. Okay, now see how the resistance will vary with the temperature. There is a formula which is R equal to R naught 1 plus alpha delta T. So this is important. Suppose we have changed the temperature of the resistance by an amount of delta T, then our final resistance will be R naught whole into 1 plus alpha into delta T. R naught is the initial temperature and alpha is the temperature coefficient. Okay, now let me show you the combination of resistances. Now first see the series combination. So series combination is just like suppose this is a R1 resistance, this is R2. I have taken only 3 resistances. There may be many resistances like this. Okay, and this is a potential applied to this circuit. Now see, there will be current flow I due to this potential difference, and the same current will flow through all the resistances. Okay, then what will happen if we apply Ohm's law, which is V equal to IR? Suppose V1 is the potential drop in R1, V2 in R2 and V3 in R3. Then V1 will be I into R1, as I1 current flows through this R1. V2 will be how much? IR2, and V3 will be IR3. Now see, if we calculate all this, or if we sum up all this V1, V2 and V3, we will get finally V. So V equal to V1 plus V2 plus V3. Put the values, and V will be IR, where I is the total current and Req is the equivalent resistance of all these 3. So this is IR, P1 is IR1, P2 is IR2 and P3 will be IR3. So finally we will get R equivalent will be equal to R1 plus R2 plus R3. Okay, now see the parallel combination. I will take 3 resistances as in the earlier case, R1, R2 and R3. Apply potential of V across all these 3. These 3 are in parallel combination. So see, if I current flows from potential difference, it will divide in 3 parts. Suppose I1 through R1, I2 through R through I3 through R3. Okay, and see, across these three resistances the potential difference is same because these three are connected with a common point, and this common point is connected to the plus terminal of the potential. Similarly, the other terminal is directly connected with this negative terminal of P. So in this case, potential difference across these three resistances will be same. So if I find the current in each resistance, I1 will be P by R1, I2 will be P by R2, and I3 will be P by R3. And the total current, what is the value of total current? I equal to I1 plus I2 plus I3. Okay, now see, I will be how much? P by R EQ, which is the equivalent of these three resistances. I1 is P by R1, I2 is P by R2, and I3 is P by R3. And if we cancel the potential or P, we will get R EQ equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this way we have to calculate the equivalent resistance in a parallel combination of resistances circuit. Okay, now let me show you all these things through an example. You see, find the equivalent resistance across A and B. Okay, so this is a question of finding the equivalent resistance. You see, to solve this question here, first see properly these three resistances. This is R1, R1 and R. Now this point, this point, and this point, and this point, these are all the same points because these and these points, there is no element between these 2 points, so these 2 points are short circuited. Similarly, these 2 points, this and this, also are short circuited. Similarly, on this terminal also same, this point, this point, this point, and these 3 points are same points because these are all short circuited. So we can say that these 3 are in parallel. Okay, like this. Okay, so if these 3 are in parallel, what will be the equivalent of these 3? It will be 1 by R EQ equal to 1 by R plus 1 by R plus 1 by R. So it will be R EQ equal to R by 3. Okay, so we can draw the circuit again like this. This is R, this is R, and we represent these 3 resistances by a single resistances of R by 3. R by 3 will come here, and after that these 2 resistance will come. And this point will be B point. Now see, these 2 resistances are in parallel because their terminals are common terminals, and these 2 are in also in parallel. So if you calculate the value as I show you the formula, when the resistances are in parallel, we will get the parallel of these 2 will be R by 2, and this is R by 3, and this will be R by 2. Okay, now see, these all are in series in between A and B. So R equivalent or RAB will be what we do when the resistances are in series, we simply add them. So R by 2 plus R by 2 plus R by 3. So this will be R plus R by 3, and our answer will be RAB will be sorry 3 plus 1 4r by 3. Okay, so this way we can find the equivalent resistance across any 2 points. Okay, thank you for watching guys.